guys, hope all of us are doing great. My name is Ernest and this is Ernest Sciences and Mathematics TV channel. So in this specific discussion, we're going to look at the concept of entropy and the third law of thermodynamics. And this is going to form our last bit of the discussion under the various laws that we have done on the concept of the first, the second, and the third law of thermodynamics respectively. So in this case, I had mentioned that the concept of spontaneous processes are going to be accompanied by increase in disorder. And this, of course, is going to be insofar as the concept of a system is concerned. Therefore, if we were to look at this particular case in a figurative way, we're going to see that the arrangement of our molecules are going to assume disorder as the change in temperature, of course, increases in this specific case. And therefore, we're going to, of course, create a relationship between the aspect of temperature and disorder, in a sense that an increase in temperature is going to lead to an increase in disorder, which basically is regarded as entropy. And therefore, this is going to lead to a third law of thermodynamics, which is going to consider the variation in temperature and the entropy of our systems in that specific case. So this is going to be, of course, described in a form that entropy is going to consider the purity of a substance, and of course at a specific temperature, then therefore we can be able to allocate various measurements of entropies of substances at a particular point of temperature and the pressure in that specific order. So in this case, the third law of thermodynamics states that enthalpy of a purely crystalline solid substance at a particular temperature, of course, is going to be 0, and this temperature is going to be the absolute 0 value, which is given as 0 Kelvin. So this is going to be not okay. This is going to be 0 kelvins, which is regarded as, or 0 Kelvin, which is regarded as absolute 0. So we're going to consider the entropy of course, pure substance from the value of T equivalent to 0, and the value of the temperature, which is perhaps equivalent to T given as such. So the change in temperature in this particular case is going to be between the initial value of 0 to T given in terms of kelvins given as such. So therefore, this third law of thermodynamics is going to give temperature changes of a substance between T1 and T2, as we have been doing, which is going to be done through calorimetric measurements, and then of course it's going to be refining this particular aspect of entropy. So if we consider the case of increase in temperature, we can be able to define the entropy increase by giving this specific algebraic representation, whereby S is representing entropy at a temperature T2 minus S representing entropy at a temperature T1 given as such. And this is going to give us the difference in entropy between temperature 1 and 2. And that can be attained through the integral of this specific value for the molar heat capacity at constant pressure, and of course that value for dt over T given as such. So we have already derived this specific equation. I'm going to give a link in our description box so that we are able to understand that specific representation. So this is going to be given in terms of T2, T1, Cp d, the natural log over T, given that specific representation. So this implies that there's going to be change in temperature, and of course this is going to be molar, the molar heat capacity at constant pressure given as C subscript P. So this means therefore that an increase in entropy of a substance between the values I've mentioned for 0 Kelvin and T can be given using this specific formula. So this formula is going, as I said, of course, in consideration of this specific entropy at a value of this absolute temperature, we can be able to give, of course, the change between ST1 and or ST generally minus S0 given as the value over these two specific entropies, the integral between 0 and T, and that is going to be Cp dt over T given as such. So this is basically the fashion of this equation up to this point, but we are considering ST1 as this specific entropy at the 0 Kelvin value, and therefore that's going to represent the entropy value of ST at that specific point. So this particular law enables us to, of course, find various expressions. Now that we said that this particular value is going to be given as a 0, so it's going to be given as a 0 at this specific value, whereby the temperature is going to be given as 0 kelvins respectively. So from this we can be able to obtain the absolute entropies of course, various substances using this specific procedure that I've mentioned of measurement. And of course, these are going to be the standard entropies or the standard entropies of various reactions, as we're going to see, of course. And of course, I'd mentioned that basically the standard entropies are going to be the differences between pure separated products and reactants. And of course, these are going to be considered, as I mentioned the concept of a standard, they are going to be considered under the case of a standard temperature and pressure. And in our discussions, we have been mentioning about this standard temperature and pressure, which are, of course, 1 atmosphere and 25 degrees Celsius are given as such. So a range of values which are going to be obtained of a comparison over these pure separated products and the reactants are going to constitute the standard entropies, and are going to be given in form of this the superscript that we normally put using this small 0 accompanying this specific symbol as such. So in our next discussion, we're going to give an example of a representation of these specific standard enthalpies, and we're going to use an example by through maybe solving one example which is going to shed light for us on how these standard entropies of substances are going to be applicable in a subsequent discussion. So that is it for now, guys. I hope that this has been, of course, relevant for us. And of course, there are various other links that I'm going to put in our description box of this specific video. Kindly check them and also engage us in the comment section so that we can be having, of course, a feedback on various topics that we've done and what we can do, of course, to make them an improvement or do better. So that is it for now, guys. Kindly check find out also links on social media and other various platforms, those which are going to assist us in creating a connection. So this for now. Bye. God bless you. Catch us in our next video.